minus 12x. And the first thing that you do when you're solving a graphing problem is that you find your x-intercepts. And to do that, all you do is you take x cubed minus 12x and you set equal to 0. And the next thing you can do, you can factor out an x, so you have x, and then inside x squared minus 12. And since you have an x on the outside, you can just set that equal to 0 over here, so one of your critical points is going to be 0. And then when you factor x squared minus 12, you get x minus 2 square root of 3, and then x plus 2 square root of 3. And that gives you x 2 square root of 3, x negative 2 square root of 3. And those are going to be all of your x-intercepts. And then for the y-intercept, you just plug in 0 for all of your x's, and that just gives you 0, 0. And for the next part, you're finding your critical points. So you take the derivative of x cubed minus 12x, and you'll move the 3 in front of your x, so you'll have 3 times x, and you do 1 minus your original exponent, so 3x squared minus 12. And to find your critical points, you set your derivative equal to 0, and you solve again. So you can pull the 3 out, and you'll have 3x squared minus 4 equals 0. And then when you factor x squared minus 4, you get x minus 2, x plus 2. And if you do the same thing as you did up here, where you just set x equal to 0, you'll have 3 equals 0, and that doesn't work, so you can just leave that alone. So your critical points are just 2 and negative 2. And the next thing we have to do is you have to test where it's increasing and decreasing in your function. So you'll put your numbers on a number line with negative infinity and infinity, and you will take your critical points and test parts in between these intervals to figure out what part is increasing and decreasing. And you're going to use your first derivative. So I use points negative 4 to test in between negative infinity and negative 2, 0 in between negative 2 and 2, and then 4 in between 2 and infinity. And when you do all that out, you're going to get, when you start here, you'll have 3 times negative 4 squared minus 12, and you get 36. And because it's a positive number, you can put a positive over here above this interval, so you remember that you got a positive number. And then the next one, you'll do 3 times 0 squared minus 12 and get negative 12, and I put a negative right here. And then again, 3 times 4 squared minus 12 equals 36, and you put a positive there. And then when you look for increasing and decreasing, you're just going to look at all the intervals that are positive or negative. And for this case, you're going to have positive intervals between negative infinity, negative 2, union, 2, and infinity show that both of them are increasing. And then the only part of your function that's decreasing is negative 2 to 2 from right here. And now you're going to want to figure out where it's concave up and down to figure out where your min and your max are going to be. And to do that, you're going to use your second derivative. So if you look back here, you're just going to go from this right here. And the only derivative you're going to get is 6x, and then you're going to solve for 0. So if you do 6x equals 0, you're going to divide by 6, and you can't divide 0. And do the same concept again that you just did here. You're going to put 0 on your number line and do from negative infinity to 0 to infinity with, over here, I did my work. And I wrote just on here what I got for them. So when you plug, you'll test points again, and I used negative 1 and 1 to go in between these two intervals. And when you do that, you'll get 6 times negative 1, which equals negative 6, and then 6 times 1, which equals 6. And your concave up function is going to be the one that's positive. So it'll be from 0 to infinity, because our number is positive when we get 6. And then for concave down, it's going to be where it's negative. So it'll be negative infinity to 0. And then the next thing that we do is when we take our critical points and we plug it back into our original function of x cubed minus 12x, because that'll show us exactly where our max and our min are. So you'll take your critical points, which are negative 2 and 2, plug them back in, so you have negative 2 cubed minus 12 times negative 2, and you get 16. And that'll be your max, because it goes from negative 2 to 16. and then you plug it in again with 2. 2 cubed minus 12 times 2 is negative 16. So your min will be at 2, negative 16. And then after you have all of that, you can take all of your points and put it onto your graph, and you'll get your graph. So you put your x-intercepts, which are negative 2 to the square root of 3, 0, 0, 0, and then 2 square root of 3, 0. And then your max, which is negative 2, 16, your min, 2, negative 16, and then you just connect the dots and put it all together, and that's how you get your graph.